it'll all come together today. So this one, of course, was the root of 225 over the root of 48. And 48 doesn't have a root. It's not on our list, so that's why that one's irrational. And then the rest are pretty self-explanatory. Ends up being 1/2, 1/5, 0, irrational, irrational. This one, a lot of people say is irrational because 5 and 20 don't have roots. But of course, you would simplify it because you always simplify fractions to 1/4. And then it's root of 1 over root of 4, and it's 1/2. So I expect not many people had much trouble with 93, right? It's pretty no problem-y, yeah? 94 will have caused you some problems because there were numbers that were off of our chart, yeah? And I said try not to use your square root button. So this one you knew was irrational because you had the cube roots up to 1,000. And this one, it was a guess. Most likely, a bunch of you probably caved and got out your calculator. That's fine. It's irrational. This one we did together because we broke it down. This one broke down into 125 times 27, which both have a cube root, so it's 15. This one broke down into 729 and 100. Now, you might not have known 729 had a square root, but it was 27. But you knew 100 did. So if you just did this side, I would have been happy, right? Because after today, you're going to know what really to do with these. This one was irrational. These all worked. But like I say, most of you probably wanted to go to your calculator for these, and if you did, I can't stop you, that's okay. But like I say, after today, you're going to know what to do with these. This one is 196 over 225. They both have a square root. Irrational, that's on our chart. This one always causes kids trouble, because that is 125 over 1,000. So it's the cube root of 125 over the cube root of 1,000, which is 5 over 10, which is 1/2. And this one, I didn't finish that one. Oh, there it is. 5 over 3 somehow moved over there. 5 over 3 and irrational. Everybody cool? Rylan. Yep, of course. Because what Rylan is saying is this cubed root of 125 is 5, right? And then every time you multiply, you move the decimal one spot, yeah? So that's why this is 0.5, because that decimal had to move 3 times to get back there. Everybody cool? All right. If you could all then go to 96. You can see I have old notes sitting on 96 that I got to get rid of. So radical, anytime you see that symbol. Now, up until grade 10, that symbol has always been a square root or a cube root, right? But we've already talked about how there's more than that. This symbol is asking for a group of equal factors. And what tells us how many factors we're looking for? That little number right there, which we talked about a couple of days ago. Does anybody remember what that little number is called? It's okay if you don't. We only talked about it a little. It's the index. If there's no number there, how big a group am I seeking? A group of 1? 2. Normally, what's the number that we don't write in math? We normally don't write 1, but in this case, you can't possibly have a group of 1. So the smallest group you can have is 2, so we don't write 2. Okay? Equal factors of the radicand. And we remember the radicand is what's under there. What's under there? What's under there? What's under there? Thank you! I made you say underwear. It only took 5 tries. Did you guys say it earlier? Oh, you did? You got to say it louder, Malik. All right. So everyone is good? Okay. Notice I have 2 different adjectives here. You can be an entire radical or you can be a mixed radical. An entire radical is the symbol and a radicand. A mixed radical is some number, a coefficient multiplying a radicand. And this x is multiplying. Okay? This is exactly the same. It behaves just like 3x, right? That means 3 times x. Well, this means x times whatever that root is. Is everybody cool? Okay. Now, Nathan has asked, what does all this have to do with the prime factors that we started with? This whole section of the unit, right? Right now we're about to find out. Does 72 have a square root on our chart? No, we already did this in our notes. It's halfway between 64 and 81, right? So it's irrational. So we can't, it doesn't actually exist, right? Because the decimal goes on forever and ever and ever. So what we do in math class is we don't like that decimal that goes on forever and ever and ever and ever and ever. Because to answer the question properly, we would have to be writing every decimal forever and ever and ever and ever and ever. How many questions could we answer in our lives? 1. And would we ever get the right answer? No, because the decimal goes forever. So this is what we do. If we are converting to the lowest terms mixed radical, that means my answer is going to have some number, a square root, and then a radicand. That's what I need to get to. Right now, I only have the radicand, yes? Okay. So square root of 72. Since there's no little number there, what am I looking for? Groups of 2, right? Now, right now, I have no groups of 2 because there's only one number under there, correct? Okay, take 72 and do prime factors for it. Make a tree or use the stairs, whatever you like, okay? However you do it. Prime factor this, as if we were doing GCF or LCM. And we get 2 cubed times 3 squared. Does everyone agree? Okay. So we all agree that 2 cubed times 3 squared equals 72. Yes? 2 cubed is 8. 3 squared is 9. 8 times 9 is 72. We're all cool with that, right? So if this equals 72, what's another way I could write that? 2 cubed times 3 squared. Everyone agree? Because if that equals 72, then this is still this, yeah? Now, I'm looking for groups. How big? Groups of 2. Is there a group of 2 there? Right. So that means that can come out from under there. Agreed? Okay. So what do you think I write out here? 3. Not squared. Just 3, because I want the whole group, right? Okay. Is there a group of 2 there? Yeah. So how many 2s can I get out? I can get out one group of 2, right? Because we're looking for a whole group. So I'm going to bring a 2 out there. What did I leave under there? What did I leave under there? Thank you. What did I leave? A 2. Now, there's numbers out in front. I told you the numbers out in front are the exact same as if it was 3x. What do the numbers out in front do? They multiply. So what is this? 2 times 3, which is 6 root 2. And that is the actual answer. Is everybody cool? Now, you can see we're going to practice it a lot, okay? The first thing we're going to do is practice it the longest way possible, all right? The way that takes the most amount of work to make sure everybody knows what they're doing, okay? Does everybody see what we did here? Okay, I'll rewrite this. This is technically 2 times 2 times 2 times 3 times 3, right? There's a group of 2, because I'm looking for groups, right? So out comes that 2. There's a group of 2, so I'm looking, out comes that 3. Notice that 2 was left. Everybody cool? Pardon me? It is like division with the remainder, because I can divide 3 by 2 once, and it leaves 1 2 under there. Everybody good? All right, let's look at 99. First thing to do, does it have a square root? No, we know it doesn't, because it's not on our list. So we prime factor. 99, what will divide into 99 that's prime? 11. Leaving me with 9. Then what? 3, then 3. So I have 3 squared times 11, yes? So I have the root of 3 squared times 11. There's my group of 2. So what comes out here? 3, and what stays under there? 11, and I'm done. That's how easy it is. Everybody cool? All right, so let's do 75. What am I going to break 75 down into? You're going to use 5, okay? That's going to get me 15. Now what? 5 again. That's going to get me 3. So what is root 75? It's really 5 squared times 3. Is there a group of 2 there? What comes out? 5. What stays under there? 3. Easy peasy lemon squeezy, right? Everyone's cool, yeah? All right. Everybody can do it the long way? All right. Now allow me to show you a shortcut. 80, not perfect square. We know it's not a perfect square. So we're going to break it down, right? Now I bet most of you would start with 2 here. What would you start with? 10's not prime. You'd start with 5. Perfect. That gets you to 16. I can stop now. Why? Even though that's a prime and that isn't, 5 times 16 is 80, correct? So root of 16 times 5. I can stop there. I've just told you I can stop there even though it's not prime. Why? Isabel knows.
16, it has a perfect root.
What is 16's root?
4.
So what can come out?
4.
4, leaving what under there?
5.
5. Everybody cool? Now, if you do it the long way, will you still get the right answer? So we would keep breaking down 16, wouldn't we? 2, 8, 2, 4, 2, 2. Agreed? There's a group of 2, so out would come 2. There's a group of 2, so out would come 2. What's 2 times 2? 4. What did I leave under there? 5. So if you get to a perfect square, you can stop, because you know what's coming out. Everybody good? Okay, so how would we do 300? You would use 5?
3.
I would use 3. Why?
So it's the 100.
Because that then becomes 3 times 100. Does 100 have a perfect square?
Yes.
What is it?
10.
So what's coming out?
10.
10. What stayed under there?
3.
3. If we did it the long way, 3, 100, 5, 20, 5, 4, 2, 2. There's a group of 2. Out comes 2. There's a group of 2. Out comes 5. 2 times 5 equals my 10, and I left the 3 under there. Everybody good? So, do I need to know my perfect squares? No. Will it save me a crap load of time? Yeah. You guys do EFG. Not BFG, EFG. I didn't mind that movie, but the book was better. It was scary, yeah. But Roald Dahl's books are all scary. Everyone thinks they're for kids. But let's be honest here. When you're reading Charlie and the Chocolate Factory, you don't know that those kids aren't dead. Spoiler alert. Sorry. Mike TV and Violet Beauregard and I can't remember the rest of them. They all come back in the end. I don't want you to read it and cry. Nobody told me they weren't dead, Dave, and I thought they were dead. It's okay. First of all, you should read Charlie and the Chocolate Factory. Secondly, you should see the original Charlie and the Chocolate Factory from 1971. Willy Wonka and the Chocolate Factory, not the Johnny Depp one. Okay. What's 63? It's 9 times 7, right? What's the square root of 9? So it's 3 root 7. What's 32? I use 16 times 2. Why would I use 16? Because it's got a square root of 4 root 2. What's 363? 3 times 121. Why use 121? It's got a perfect square. 11 root 3. Is everybody cool with the basics? Now, believe it or not, that's not hard, right? That will get you through everything to do with radicals until the 12th grade. But you got to know how to do it. Turn the page over. We're working the other way now. Okay? If there's a 2 out in front and there's no number there, how many 2's had to be back there? 2. So this is the square root of 5 times 2 squared, which is what? 5 times 4, which is 20. Everyone agree? Okay. It would be root 20, yes. If there's 1 7 out here, how many 7's were under? 2. So it would be 29 times 49, which I can't do in my head. We'd use our calculator. 1,421. Everybody cool? Everybody cool? Okay. If there was 1 6 out there, how many were under there? 2. So that's the root of 4 times the root of 6 squared, which is 4 times 24, or 4 times 36, which is the root of 144. Right? Now, this one's tricky. Why? It's negative. Now, we know that square roots are very closely related to exponents, yes? Right? And we know that this and this are 2 different things, aren't they? Is it A or B, do you think, that applies here? It is A. This is saying negative, then all of this. So how many 5's would have been under there? 2. 12 times 5 squared, which is 12 times 25, which you all know from money is 300. Right? Everyone is good? Everyone can work both ways? Or do you want to see a couple more of these ones? Okay, don't write them down then, just think about it. What if I gave you this? What's different? There's a 3 there. So if there's a 3 there, that means how big a group came out? 3. So how many are going back under there? 3. Notice 3 cubed means 3 cubed is back under there. So that is 2 times 27, which is the cubed root of 54. Everyone cool? What if it was x root 7? That's tricky. It would be the square root of 7x squared. Nice. Everybody good? I don't even know how you made that sound. I don't know what part of your body moved to make that sound. Let's just pretend it didn't even happen. Is everybody good? Yeah? Okay. So now we're going to work same thing. It's just like the number 1 example, except what's changed? I need groups of 3, don't I? So if you don't have your perfect cubes memorized, this is going to take a little longer, isn't it? Let's do the first one together. 54, what do you want to break it down to? You want to use 3? No problem. That's 18. Then what? 3 again? Okay, no problem. That's 6. Then what? 3 and 2. Is there a group of 3 there? What is it? So what's coming out? 3, and what stayed under there? 2. Everybody agree? Now, I know my perfect cubes. I have them memorized. So I go 54 divided by 2, and I get 27. Can I stop there? Why? 27 has a cubed root. It's 3. And I left a 2 under there. Is everybody good? Who decides, one sec, Satjo, who decides which method you want to use? You do. The more practice you do, the better you will the better you will get at seeing the shortcut. Okay? Satjo. Where? That's a 3. Yep. So 144. What do you want to divide that by?
12.
You're going to use 12. That's not a prime number, but it's going to be okay. Trust me. 12 and 12. Agreed? Now, isn't 12 2 squared times 3? And isn't this 12 2 squared times 3? How many 2's are there? 4. So how many are coming out? 3 of them. So I'm going to bring out a 2. And what did I leave under there?
Oh, no.
I left 1 2
And 2, 3.
and 2 3's. Is there another group of 3 there? Nope. So it's 2 cube root what? 6 times 3 is 18. Everybody good? Now notice, Helia did not use prime numbers here. But you can do 12 in your head. So it's okay to not use prime numbers, depending on how good you are at your division and factoring. Everybody cool? Again, it comes down to you personally, what works for you. I have some students that do the stairway all the way down for every single question, and they get so fast at it, they can do it as quickly as I can, stopping here. It just depends on you. Everybody good? I'm going to do one more, and then I'm going to let you do the rest, just this page. What's different in C? It's a group of 4 we seek now. Does our method change? No. 128, 2, 64, 2, 32, 2, 16. I can stop there. Why? Because I know that 16 has a fourth root. It's 2. 2 times 2 times 2 times 2. I've practiced enough. I can stop there. If you can't stop there, you just keep going. Right? So for me, this becomes the fourth root of 2 cubed times 16. 16's got a fourth root. I know it's 2, so it's 2. Fourth root, what's 2 cubed? 8. Everybody good? Easy, right? It's just dividing. You guys do DEF. Jenna, are you always left-handed? It's usually something I notice. One year I should make a few of these books left-handed.
You'd have to make it so the book is like this though.
No, I would just switch it so the first page was at the end. So you were always writing away from the ring. Or writing towards the ring, I mean.
That doesn't change.
Yeah. Are you left-handed too?
Because you go like this and then you still have to do like that thing.
Yeah, you're right. It wouldn't help. Yeah.
So you have to have it like.
Yeah, I would have to go vertical. That'd be a giant pain in the butt. All right. Anybody have an answer for D for me? What is it? 3 what? Go for Myers. 8. Sweet. Okay, should he bring stuff? Okay, bye. Mr. Schwab. It's like, this has never happened to you. Not in my class. I can't speak to other classes. No, you don't need your stuff. You'll be back. So it was 3 fourth root, what? 2. How did you do it, Satjot? How far did you break it down? All the way? No problem at all. So Satjot went 162 divided by 2, 81, divided by 3, 27, 3, 9, 3, 3. Right? Now, he could have stopped at 81 because 81 is 9 times 9, and 9 is 3 times 3 times 3 times 3. Right? Okay, what's E? 3 cube root 4. Because that, 108, is the cubed root of 27 times 4. Out comes the 3, and we leave the 4. Square root of 108 is 9 times 12 is probably what most of you used. You brought out a 3, and you left a 12 there. Is that okay? You're halfway done, because what's 12? 4 times 3, out comes a 2, and I get 6 root 3. Is everybody cool? And that's how we read it. 6 root 3. 3 cube root 4. 3 cube root, or fourth root 2. Everyone's good? Alrighty. Turn the page over. Do these 3. You might need your calculator. Try to save a bit of room, though, because I want to do a couple of more here that are a little bit tougher because you guys are getting this very, very quickly, and I want to make sure you're actually getting it or if you're just following the steps. So remember, entire radical means there's nothing out front. There's only a radicand. You've already done a bunch of these, except it's now got a different index. What's this guy? Cube root of what? 108. 108. Because if there's 1 3 out there, there were 3 3s underneath. What's this guy? The 4th root of what? Pardon me? 6,480? Let's check. 6 to the 4th is 216 times 6 again, which is 1296 times 5. Yep. Everybody cool? And what's this guy? Cube root of 875. Now remember a couple of days ago when we were messing around with the big numbers? All they are the little numbers multiplied together. Everyone cool? Now, in this space right here, I just want to see if you are actually understanding what's happening here, okay? We're going to do 2 different questions here. We're going to do one like number 3 and one like number 4. The first one is this. I want the square root of 18x cubed y to the 5th. You do know how to do it. Make this look like a mixed radical. This one should make you think. And it's even okay if you can't do it. What's freaking you out in that one? Is it the 18 or is it the x and the y? It's the x and the y, right? So let's do what we know. What's 18 break down into? 9 times 2, right? Why would I use 9? Because it's got a it's perfect square. So out will come a 3, agreed? All right. And we know that a 2 is staying there. Right? Now, isn't 9 really 3 squared? Because we were able to bring out a group of 3. Well, how many x's is that? How big a group am I looking for? 2. So can I get an x out? How many groups of 2 can I get out? 1 x. Was there a remainder? What was the remainder? 1x. How many groups of 2 can I get out of 5? I can get 2 groups of 2. Was there a remainder? What was it? Y to the 1. Everybody cool? That's grade 11 pre-calc. Easy to do, right? It's the knowledge you already have, taken one step further, knowing your exponent laws. Yeah? Okay, now I want you to do the opposite. I've got 2xy squared cube root 3y. I want this to look like one of these. Nothing out front. Just like exponents, remember, do numbers, then letter, then letter. Does anybody want to say their answer? Nathan? 24x3 y to the 7th. Does anybody else have that, or does anybody have anything different? I'm not saying that's right or wrong, so if you have something different, you could try. Jacqueline? Okay, you have a 6. Yeah. Okay. All right. Jacqueline, you were right in bringing stuff under. You didn't bring it under quite right. Nathan, you are right. So, why was Nathan right? If there's 1 2 out there, how many 2s are under there? 3. So there's 2 cubed times 3. What's 2 cubed? Now what you did, Jacqueline, you did 2 times 3.
I thought it was the 2 and not 3.
Yeah. Oh, okay. So 2 cubed is 8. 8 times 3 is 24. Everyone good? If there's 1 x out here, there had to be 3 x's under there. If there's 2 x's out here, 2 y's out here, that means I needed 6 y's under there, plus that 1 to make the 7th. Is everybody good? Great. When you guys take Pre-Calc 11 with me next year, you've all gotten a head start, 1 free lesson in radicals. Okay? We'll share gummy bears on that day, because you all took this class, and you will all know that I don't need to go over that for you. All right, one last thing. Will you always be able to get out a pair, do you think? No, why not, Prab? You won't, right? Because if you have, what if I had the square root of 15? What is that in prime factors? That's the root of 3 times the root of 5, right? Any pairs? No. So sometimes you're done. You can't do it. If there's no pairs, you're screwed. What if it was this? 4 times 3. Oh, sorry. Cubed root of 12. Could I break that down? No, because that's 4 times 3, which is 2 squared times 3. Any group of 3? No, so it's done. Everybody cool? Just like in fractions, sometimes the fraction gets no smaller, and then you're done, right? 11 over 41, that's the smallest that's going to get. So we can't simplify it. Everybody cool? Great. Your only work today and for the weekend is to do 98 and 99. 100 is obviously extra practice. It's got the answers. Is it a good idea to do some of it? Who's punished if you don't? Yourself. Okay? Now, 99 is tricky. No calculator. If you can't figure it out, that's okay. We'll talk about it Monday. All right? But you have the tools you need to do this if you think about it. Everyone good? Great. Go. I always do this to you guys. Page 100, please notice how much practice there is there. You probably don't need to do all of it because you're all actually pretty good at this. Every time I look up, I'm seeing none of this. And I'm seeing lots of this. Which means you get it. So, obviously, you don't need to do A through J, right? Pick a couple at random. If you get them all, you're good. All right? If you have a couple mistakes, try a couple more. You listening for the ocean, Olivia? Oh, yeah, okay.